Team Shunya's second workshop. Uh, this workshop is called Using AI for Creativity. It will be conducted by Mayur Mistry. He's a grad student at the University of Illinois in Urbana-Champaign, and he was also a former Team Shunya member. Uh, we're going to start with this workshop with a brief intro about Team Shunya, and I'm going to hand this over to Kirti to get it started.
Hello everyone, good evening. I am Kirti Rathod, Assistant Events Manager of Team Shunya. I am a second year student from Electrical Department B.Tech. So let's get started. Team Shunya stands for Sustainable Habitat for Urbanizing Nations by Young Aspirants. So the main vision of the team is to become a leading innovation hub in the field of sustainability by providing accessible housing solutions for society and industry. So it all started when a group of students decided to take part in the Solar Decathlon, an international competition organized by US Department of Energy, reputed as the equivalent of Olympic Games in the field of global solar energy industry. So the challenge was not just to design the house, but also to build and operate it. So we proudly tell that Team Shunya was the only team from India to get selected for this competition in 2014 and 2018. So the Team Shunya achievements are 2014 Honorable Mention in Sustainability and 2018 Best Participation Award. In the 2018 picture, we have our speaker for the evening, Mr. Mayur, who's in the orange kurta in the 2018 picture. I hope you all can spot him out there. And yeah, this is the house built by our team members in 2014. This is one-storied building. And this house was built by the team members in 2018. Team members did face a lot of challenges during this competition, as they had to build a two-storied building and also had to charge the electric car. Okay, so the technical team is divided into 5 divisions, as you all can see, and these are the software works done by them, or which they do. Okay, so this is completely student. I wouldn't say completely student team, but yeah, faculty members also be a part of this team. But most of the work is done by the students. So before the construction and all, safety measures are taken, and the construction part is also done by the students. Okay, so this is the implementation part. After simulation and all, after simulation, construction and all, implementation. So here we can see the house built by the team members, and yeah, the construction is done by only students. So construction is the best part of the entire project. Coming to the marketing and communication teams activities. So the marketing and the communication teams do carry out many events throughout the year. We do take part in many knowledge sharing activities and also many interactions with the industry people. And yeah, we do conduct many events throughout the year, like webinars and workshops, and reach out to our audience through social media. So our team is recognized by the media, and we do have many interactions with the government initials or officials like ministers and all. As we can see, Mr. Manohar Parrikar, the Honorable Defense Minister of India, and many more like Dr. Vijay Kumar Saraswat, renowned scientist, the Director General of DRDO, and many more government officials. So since this is a very big project, it's a big budget project. So the sponsors of 2018 are, yeah, as you all can see on the screen. And these are the sponsors of 2014. Okay, coming to the faculty advisors. So these are our faculty advisors who guide us throughout the project, and without their help and guidance, we wouldn't have achieved what we've done till now. Yeah, so this is the team head, the main team. Yeah. So let's get started with the event.
Uh, all right, can you hear me well? Awesome. Right, I am sharing my screen. Okay. First of all, I would like to thank Team Shunya for this opportunity. So, in this workshop, I'll be sharing tricks and some algorithms which are used by top AI artists. And the aim of day one is to give you a wide variety of applications. And on day two, we'll go deeper in what are the algorithms and basics behind it. A bit about me is I graduated from IIT Bombay as a civil engineer in 2017. Currently, I'm doing masters at UFI, and I'm the project manager of Solar Decathlon team in at UIUC. In my free time, I host a podcast called Engineering Architecture, where I discuss with the interviews about how we can integrate architecture, engineering, and technology to create sustainable designs. So I shared a link of this presentation earlier in chat, and so that you can also follow along with few of the links which I'll be talking about. So let's get the bigger picture of the stuff we'll be working today. So this is a famous artist called Rafiq Anadol. All right. So this is the bigger picture. Today you will be exposed to tools through which you will be able to create a similar piece of artwork. So we'll start with two applications where you'll get hands-on experience of the tools already developed online, and we'll do style transfer with hands-on coding, and next is latent spacewalk demo. So just to give you a picture of what we will be doing, so this is a glimpse of style transfer where you take a style image and have a content image, and how you can transfer the style from that style image to your content image. So as you can see, this is the style image and the stylized transfer. So by the end of this day, you will be able to select your own style image and produce a stylized trans- transfer. So this is our demo one. This is second demo where had a trained data set on Indian architecture buildings and how one can create a latent spacewalk using those trained data. All right, right. So One caution I would like to share is the concepts I'm describing are very technical, and generally these are being it takes couple of days or weeks to go in depth. So it's perfectly normal if at some point during the seminar you feel a bit overwhelmed or there's a lot of information going on. It's totally fine. You can post your questions on the chat, and tomorrow we'll be able to address all those questions and go deeper into the technical aspect. So the intent today is to play and give you an introspect about what are the ways you can use this technology for your creative explorations. All right. So have you ever imagined how a sketch or a scribble made by you can be converted into a realistic image? So let's do this exercise. Is everyone able to follow along the presentation, or should I share the link as well in the group chat? Okay, I think it would be better if I just share it on the group. Mm, Sorry about it. Can any of the organizer share this link in the chat box? Oh, I see the chat. Okay. So let's do this exercise together where we will sketch something and you will be able to see how that sketch is transformed into a realistic image. So you can select any image which you want, but first you need to take this. There are various elements which you can draw upon. So let's start with tree. Just paint it, and there you can see the transformation. You can even make all this. You can even change the final output. So as you can see, this is a type of GAN, and it produces a realistic image based on the data it was trained on. All right. So this was the first exposure. Now we will see how we can use machine to sketch together. Let's say I want to make a face. All right. So as you can see, it, it adds another dimension to your creative explorations. And I have shared many other websites which you can play with, and each website is trained on different neural network with a specific purpose in mind. All right, so let's start with our first demo, style transfer. And since we are covering a couple of topics today, if you feel I'm going too fast, feel free to comment it so I can adjust my pace accordingly. So, what is style transfer? As I mentioned earlier, it's a technique through which you can recompose one image in the style of another. So, a content image, which is this one, is paired with a style image, which is this image. And then you can see how it transforms uh, the content image in the form of style. We will go into technical details tomorrow, but just for your information, this algorithm has different neural network layers, and each layer identifies different features or value. So as you can see, if I run an image through a network, uh, first layer can identify different pixel values, second layer can identify edges, and so on and so forth. So using this algorithm, I can use the edges in this layer and take that values of the content image and pair up with the features which I identify in later layers and make this composition. So that's why you can see there are edges which are maintained and which are inherited from the content image. The style is taken from the features we got from the style image. All right, so we'll start with the first demo. So we'll be using Google Collab for both of our demos. And first, I would suggest to change the runtime if it's none to GPU. And in settings, I think it would be easier to keep track if you check the show number. So, all right. And I think it would be advisable if you can make a local copy in your drive for future use. It's perfectly normal if you don't want to. Right. So the script shared has some instructions, which will help you to go along. So we'll start with, you can either press the play button or through the keyboard and do Shift Enter. We are installing TensorFlow. So in this step, what we are doing is there is files created in this GitHub repo, which has the neural style transfer algorithm and coding files. And what we are doing here is making a local copy on this. So once you finish this part, you will see a folder which has all the files downloaded from this link. Oh, I can share the collab notebook link. So once you have this, let's check whether we are in the right folder. So it's content/neural style transfer. Let's do a basic style transfer. So as discussed earlier, how it works is you give a content image and a style image. So there are few examples which are already loaded in this directory. So image input reflects to our content image, as I discussed earlier, the content image. And styles refer to style which we want to recreate. And you can have a look. If you double click on this, you'll be able to see what are the different images loaded. Yeah, so those are images are under, if you click on this folder neural style transfer, image input, you'll find those images here, Ashish. All right, so let's do a test run on the existing images, and later what we can do, we will upload our own content image and style image and see how the transformation looks. So we'll just play it for. So right now we don't need to upload any image because we downloaded the directory from GitHub. It has some images built in. All right, I will repeat the initial steps. So first is you set up your runtime to GPU, and we just had two code blocks ran. It was TensorFlow and the library. So you just hit the play button. Sometimes it takes around 2 minutes to do the style transfer. So GPU is runtime, change runtime type. We had one question about runway I saw earlier. Yeah, so there are other platforms which you can use to do this exercises. Runway is one, but you need to pay to do experiments over there. And moreover, I wanted to use a medium where we don't require any software installation and everyone can participate and experiment. Even you can use virtual machines from Google or Amazon to perform this exercise. All right, so the style transfer exercise is done, and let's just view what's the output. So after we selected the input of content and style. All the images which we had an input on will be saved in image output folder, as you can see. So this was our content image. Line. We wanted to have a style transfer of this, and this is our final image after style transfer. All right. Is anyone facing any problem? I'll just wait for 30 seconds because some people got the link late. Yeah. So in next step, what we'll do is we'll upload our own image for content and style transfer. So if you have finished this exercise, I would ask you to select any image of yours which you would like to perform this exercise. Let's see. Hmm, I'll just select this image. Oh, yeah. One thing to keep in mind is we would like to have either PNG image. It's also in the code. PNG or JPG. I just downloaded JPEG, so I'll look. You can name whatever you want. So this is a style which I'm will be transferring, and the content image would be one of my personal photo. So let's move on to the next part. Let us all upload an image. So right click on the image input folder and you will see an upload sign. Let's go to, I would like to transfer it. Yeah. One thing to keep in mind is all these files are stored in a virtual machine. We have like this much space. So once the runtime is over, these files will be deleted. So I hope everyone has uploaded their content image. Let's upload the style which we want to transfer. There are also pretty good examples built in. So if you want to use these examples, study. All right, let's upload one of our style. So it's called style one JPG. So once you upload those two images, all you need to do is replace this part after content image with the image you uploaded. So my input file was download.jpg. Uh, the style I want to transfer was style1.jpg. I'll just repeat. For the next step, if you want to do some style transfer on your images which you would prefer, you just upload it in image input and style folder. After it's uploaded, you have that name in these two variables. Right, let's do it. Can I get some comments on the chat if everyone is able to figure that out?
So we have some doubts like how to upload and what to do after the GitHub.
Sorry, did you say something?
So I was saying that there are doubts like how
It's
to upload and what to do after the GitHub.
it's a bit unclear, but what I got was how to upload was one doubt. Yeah, I'll show it. So all you need to do is, let's say once you downloaded your folder, click on it, right click on image input and upload, and just select the image which you want for content. So that is content image, and you do the same thing for style. Upload and whatever image you want as a style. And once you do that, just replace the content image with the image you uploaded and style image with the name of your style image. So it's visible. Let's see how it, and all of your results are stored in this image output. So let's verify. Yeah, okay, this was our content image. Correct. This was our style image. Let's see the results. Yeah. So as you can see, it kept semantics of content image and transformed it. If you would like, so every time it will replace the content which was in this folder. So either you can download it or you can just rename it. So next time when we run this operation, it will create another 1,000 folder and your data from the previous operation will be saved in another folder. Can I get some comments if you're able to successfully do the style transfer for your uploaded images? Yeah. So once you upload those images, all you need to do is replace this value with your uploaded image. So let's say the name of my uploaded image input was abc.jpg. Then I would write abc.jpg here, and the style image was xyz. Then I would write xyz.jpg. So current, to display the images, all you got to do is just click on the final results and double click on this file, and it will show you the results in this area. Okay. Are there any other problems which you're facing? You can't see the image output folder in there. Did you run the operations? Did you? Hmm. Maybe just refresh it. So click on this. Yeah, it should show. All right. Is it because Bhavya, can you hear my voice clearly, or is there any lag in that? I can change the mic settings
We
if
can
needed.
hear you.
Okay, awesome. Let's do another exercise. Any suggestions? Let's just do a random experiment. How it will predict this. Oh, it's JPEG. No, I'll just use this. Let's do a similar exercise where we will upload this image in style. So it's uploaded as a robot. We'll place it. Shivam, you need to change names in this line. If you- I'll just quickly give you a demo. So once you run these two files, you can even change names here. This is just a test run. And just change the variable of content image and child image. All right. Yeah. To manipulate the intensity and other parameters, there are various options here. So let's say you want to change the size of final output. You can play with the maximum size variable. So if the current image is 600 pixels and you want 1000 pixels, you can do it over here. If you want to change the parameter of iterations, you can do in this part of the code. Just change this number and you can see the difference. Yeah. So once you know how the algorithm works, it's pretty easy. The codes below have few additional parameters which you can play with. All right. I think if it cannot find directory, are you sure you played this code block? Because then it will first download the whole directory and change the directory to this folder. And see, it will be able to keep track of our current directory. Let's see how the robotic transformation looks like. This was our content. Oh, it took only that part. As you can see, this is how the transformation looks like. All right. So there are a lot of iterations and parameters you can play with. So since we have another demo and exercise coming up, I need to discuss, and we are 8:20 already. Oh, it's my time. I'll move on to the next exercise. So for tomorrow's session, I think if it would be great if you can do 10 experiments on this exercise. Either you can play with the input image, which is the content part, or with style image. And if you want to go a bit more advanced, then you can also go to the script below and manipulate with the sizes and yeah, iterations. Okay, let's move on to the next part of the demo. StyleGAN. So the theory for StyleGAN we'll discuss in detail tomorrow, but just to give you an overview, what it does is based on the input data, it, it extracts features of that data to produce new data. That's why to make a good StyleGAN model, it's very crucial to have a good diverse data. It's recommended that you at least have 1,000 plus images. So what is GAN? The way GAN works is there is a generator which tries to create realistic images, and there is a discriminator which checks images based on your input data and classifies whether it's fake or real. So that's why two neural networks are constantly fighting against each other to prove to make realistic images. That's why this power model is so strong to create realistic images. So for our exercise, we'll be working on an image set which is around 1400 images on Indian architecture temples. Tomorrow we will discuss what is latent space, what are feature vectors. But few steps which I would like to share is in StyleGAN, the way it works is you prepare a data set of 1,000 plus images. Either you can create your own, if you want to, let's say you want to create a style of all the food dishes you eat, then you can collect all the data of those dishes, and then you can use this model to create a style out of that. So depending on your interest and intent, you can collect that data and train this model to create a style from that data. So step one is generating data set. Step two is training that data set. And training takes a bit of time. So the model which I'm sharing, it was trained for over 20 hours. But the more time you spend on training, the better it gets over time, and the feature vectors are better. But it also depends on the data and lots of other variables, which I won't get into. So let's see how this works. So in this demo, since training part takes a lot of time and generating data set is also time consuming activity, and we have a limited time. So what I'll do is I'll do the latent space part in a demo exercise, and I'll share a link of a video which will help you to create your own style and how the training works and how to generate data in the link. So I think in order to do this exercise, you need to have uploaded the two files which the organizer shared with you earlier. Yeah, yeah, we'll do the same runtime, change runtime, GPU. And my options might differ a bit because I have Collab Pro, but you can change GPU. Let's see. We'll play this. In this code, we are mounting data from our Google Drive. So all you need to do is click on this link. Just select whatever account you need to link. Copy this code. Now you will be able to see all the files of your Google Drive. So we mounted. Yeah. So in order to perform this exercise, you need to have access to the pickle file, which is the train model, and it's npz file. Without that, you won't be able to proceed to the next step. So it was the folder IIT webinar files which we shared. So apart from these two files, we need a repo of StyleGAN. And I think it would be easier to just remove this part. Plate. Our intent is to create a copy of StyleGAN from this link. I'll wait a while. Yeah, it will ask for an authorization code, and all you need to do is click on the link and copy paste for that link here. And the reason we are doing is we want access to our files from Google Drive. After that step, we created a copy of StyleGAN, and I just modified and deleted the rest part of the code so I can access it from here. What kind of error? I think if you play, can you play this code block again and ensure that you copy the values? Just to be considerate of time, I'll move on and we can discuss the error later. So once you do a local copy, for path to TensorFlow StyleGAN, this is important step. You right click, select copy path. So wherever your StyleGAN folder is, just paste it. After that, we need to share the path of our train model in the which is in the format of pickle file. So we'll go to the directory IIT webinar files. This is our pickle file. Right click, copy path. Paste it over here. We'll do similar for this file. Right click, copy path. Replace. So 3 changes. One is sharing the location of StyleGAN folder. Next is a train model and the component vector folder. After that, just hit play. And you don't need to change anything in this part of the code. All right. So for this part, once you clone this StyleGAN folder, just right click on this folder, do a copy path and paste it over here. Then once you have uploaded the files we shared, you can share the path of PKL file and paste it over here, and similar for the vector. Okay. If you have your Google Drive mounted, then you will be able to see this drive folder. If you're, or maybe just refresh it, it's not visible. Okay. So now since we have loaded the model, in this part of the script, either you can assign a value from 0 to 20 over here, or you can comment this part and make it random. Let's just select any value. I'll select 3. And yeah, if, if you play it, this value should reflect over here, loaded component number 3. So all we are doing is we have a train model and we created a GAN space from that train model, and that npz file has the vector information of those feature vectors, and we are just picking one feature vector and through this value. And once you load that component, you need to run UI, and sometimes it doesn't work in first place, so you might need to click twice. So now we have that vector loaded. You can move in that vector space through this variable. In this tab, just type any name which you would like to call this component. This is component 3. I'll just write com3, enter. You can write whatever name you would like, and it will reflect over here on com3. What is the step before uploading this style and model? Yeah, so there were only 2 steps. First is playing the script and playing this part. So it will generate a link which has some values, and you need to copy those values to link your Google Drive. Those were the only 2 steps. Okay. Now after we have loaded the UI in 3, we should change the name of this variable to the component we named here. So let's see, it was com3. You can vary the value of this number of samples, and depending on the duration of the animation movie, you can change the number of frames. I think 50 frames generated around 10 seconds of clip, depending on the total duration. You can do that. All right, so let's just create an animation. The animation would be saved in StyleGAN and out folder. I'll repeat it. Once you finish running this code, the results are in the out folder. You just download it. Another thing which you can do to save time in future, or if you don't want to do the tedious task of downloading it every time, instead of having this StyleGAN, in this part of the code, we created StyleGAN on this virtual machine. But if you want to save all of your files on your personal drive, can just change this path to any folder in your drive, and all the files would be saved on drive. But since I was not sure if everyone would have sufficient space on their drive, I just created on the virtual machine. But you can change that later. Let's see how the movie is. Yeah. So different component will have different features associated with it. You can see that in this animation, it's able to identify what are the different column components in this architecture. And you can create a lot of different animations. Uh, let's say you want to check another component. I'll just name component 8. I'll wait for 15 seconds so that everyone is following. Once you change the name of the variables, you run this code block, you load the TensorFlow version, change this component value, then you run the UI, just assign any name of this version and ensure that you copy the same value over here. You can manipulate the number of samples, scale, frame rates. Let's do another run. I think let's just do 9 and see how it goes. Oh, so we have loaded component 9. See, like it didn't play in first go, so that's why sometimes you need to click twice. Okay. Let's name it component 9. Hit enter. You can see it has generated numpy file. Change it to component 9. Let's play. Let's see. So this is our new animation video. Is anyone facing any issues? Let's see. All right. So the goal for tomorrow is create 3 animation video and play with the component value in different variables which are under this part. We're getting error in the third code. Yeah, did you change this on the CD? Because initially it was linking to one of my folder in the drive, so it will give an error if you haven't changed this part. Okay. So either you can create here, or if you want to locate it on the personal drive. What you can do is you can create a new folder. In case you want to store every file on your drive. One thing which we should be aware of is if the variables are in inverted commas, you can keep the path as it is. But if it's not in inverted comma, you need to add a slash because the code doesn't understand the space between my drive. Now you can see all the StyleGAN files are now downloaded into your personal drive. Okay. Let's move on. It's already an hour, so I'll summarize what we learned. I have also additional scripts of Google Deep Dream artistic painting, and I would like to know the participants' feedback for tomorrow. Do you want to explore more scripts, or would you like to go into the technical side of this algorithms? Yeah, I'll send a poll or a feedback so I can see. Okay, I can say in the chat box that more people are interested in technical side. Okay, we'll definitely cover the technical side. But since this is a very uh, complicated topic, I would request if you can post questions right now on which aspect in the technical side you would like to learn about. So we'll cover those aspects for sure tomorrow. And I know which part of the technical side to focus on. So I would appreciate if you can share some questions in related to technical side in the chat box. Okay. So for tomorrow, I have made a folder on Google Drive. No, it's not this folder. Sorry for that. And I just make one. There was students. Okay, I'm sharing this folder. So once you finish, let's say, doing 10 iterations for neural style transfer and 3 latent space videos, just make a folder with your name and upload your work, because once you start exploring the neural style transfer, you will realize that there are few style images which will work good for your content and there are few which won't. So if all of you will upload your work, we can learn from each other that what kind of images tend to perform well for style transfer and what kind of images don't. So everyone would be aware of in their future work. Yeah. So there is work sharing. So for tomorrow, we'll divide the part into first covering technical aspects, then learning from each other. So we'll spend some time in that. And most importantly, I would like to cover how you can build upon your skills you learned from this webinar and take it to the next level. So it will be about if you find a good research paper online, then how can you use other platforms to build upon that code or customize it to make it your own code. So we'll talk about that aspect and what are some good AI artists to follow, some YouTube channels which goes deeper in this aspect. So a list of resources which you can use to develop your skills in this area. All right, so I think I apologize for extending a bit more than 1 hour. Tomorrow we'll keep it within an hour. Yeah. If it would be great if you can provide some feedback on today's session, which will help me to improve upon for tomorrow's session. Yeah, I think we can email you all the presentations and resources. But if you have, I think the link of the presentation, it has all the demo files and other resources which you need. So if you have this presentation link, that would be sufficient. Mm. Any any comments? Yeah, I think I'll also share one PDF where it will have the Google Collab code for different artistic explorations. So in your own time, you can just use those resources. Yeah. So this is your, if you're new to machine learning, this was your first ML code application, and I hope you got good results. Yeah, I think Sujay, we can do interface. In fact, I was planning to share one script for audio reactive, which in which what it does is using those latent space vector, you can connect it to your audio file, and depending on the volume of pitch, the vector will change. So it's, I think I'll share the script, but I'm not sure tomorrow we will have enough time to cover that script. Yeah. But if you Google audio VF2,
Guys, you all can visit our Team Shunya website and fill in the feedback there for us to grow more and provide you all with what you all need more.
And to be able to receive the tomorrow's meeting.
thanks a lot for your feedback.
We'll be sending the meeting links to the people who have filled the feedback. Thank you.
Oh, sorry, I forgot to discuss this. But if you plan to share your work on social media, you can either tag me or the Team Shunya's page. So you can even look at your work. We'll share my. All right. I hope you get some really interesting results and see you tomorrow.
Thank you so much, sir.